It's September 15th, 2020. I'm Todd Dunn, and today I'm going to show you how I do my white blood cell count at home. So why would I want to do something like that? Well, the reason is pretty simple. I have a blood cancer called chronic lymphocytic leukemia, or CLL. CLL manifests by causing a particular type of white blood cell called a lymphocyte to accumulate in your blood, and that has a number of negative impacts on your immune system and life in general. So although I underwent treatment a bit over 2 years ago and I'm currently in remission, I like to keep track of my white blood cell count so that I can have, if you will, a sort of early warning if I start coming out of remission. And one reason I'm doing that is that as a consequence of COVID-19, I appear to have been put on a once-a-year cycle for having a lab blood test and a visit with my oncologist. So by doing my blood test at home, I can stay on top of any changes in my blood counts. And I can, if I see something disturbing, call up my oncologist and hopefully get an appointment a little bit sooner than once a year. Okay, so what I want to do is show you exactly how I go about doing my own white blood cell count at home. Okay, in order to do this blood test, I need a sample of blood. So what I do is I prick my finger and put a drop of blood on a microscope slide right here, and I then use another microscope slide to spread that out into what's called a blood smear. Once that's done, I dry the sample, and then I put it in methanol to fix it. That removes any excess water from the sample and also sticks the blood cells down onto the glass slide. And then I stain it using a stain called Wright's blood stain, which dyes the red cells a pale pink color, as you'll see when we look at this under the microscope, and also dyes the white blood cells so that they can be identified and easily distinguished from the red blood cells, and so that I can tell the 5 different kinds of white blood cells apart. Okay, let's take a look at my setup for looking at this blood smear. Okay, this is the microscope I use for looking at my blood sample. It is a standard but relatively inexpensive biological microscope. I bought it online for about $160. It has 4 objective lenses from 4 to 100 power, and it has, instead of an ocular lens, it has a digital camera which I can plug into my laptop computer via a USB cable. And the computer has software to run the camera on it. It also has a mechanical stage, and that's useful because I'm going to be moving the blood sample around in very small increments, and with the mechanical stage you can do that fairly precisely, much more precisely than you can just by trying to move it with your fingers. So we'll put the slide on and move the mechanical stage over. We'll hook it up to the computer and I'll show you what a blood sample looks like under the microscope. Now we're initially going to be looking at it with the 10 power objective lens, which with the camera gives us about 100 magnification. And we'll do some close-ups of individual types of white blood cells with the 40 power objective lens, which will give us about 400 magnification. Okay, let me get set up and we'll take a look at things on the computer screen. I've now got the computer software fired up, and we are looking at the blood sample on the glass slide. Most of what you see there are red blood cells, these small little round cells, some of which have a little dot in the middle. Those are red blood cells. There are also some very small little cells, like this little tiny one above the red blood cell there. Those are platelets. In this particular field of view, there are also 2 white blood cells. There's one right here, and there's one right up here. This one is a cell called an eosinophil, and this one is a neutrophil. Now what I'm going to do is I'm going to use the camera on the microscope to take a large number of pictures of different locations on this slide of some of my blood. And then I'm going to go through and look at the pictures and count all of the white blood cells that I find in all the pictures that I take. And then I will take the total number of white blood cells that I find, divide that by the number of pictures that I found, and use that number to calculate my white blood count. While I'm counting the white blood cells, I'm also going to identify them in terms of what type of white blood cell they are, and I'll keep track of how many of each kind there are. And that will allow me to determine the counts of the individual white blood cells. So, how do I use the ratio of total white blood cells counted to number of pictures taken to determine my white count? Well, what I have done is, over the last 3 years, I have had quite a few blood tests in the hospital lab. And most of the time, when I've had a hospital lab test, I have, just before I went to the lab, made up a blood smear like this, and then when I got home, I counted that blood smear, and I've used the lab test result in conjunction with my counts, expressed as white blood cells per photograph, to develop a calibration so that I can then go to a sample like this, where it's been 9 months since I last had a blood test, and use that calibration along with the count of the number of white blood cells per photograph, based on a large number of photographs, to get a good estimate of the total white count. So that's relatively straightforward. So, what's the next step? Well, the next step is for me to take a bunch of pictures. And I usually take a bit over 300 pictures. Why so many? Well, it's pretty obvious. The rationale for taking a lot of pictures is that, as you'll see when I move the field of view here a little bit, the number of blood cells in the field of view changes as we move around in the blood sample. So what I'd like to do is get a representative look at this blood sample. So by taking a lot of pictures, I can kind of average out the cell density in the pictures to get a good estimate of the total number of white cells per field of view. And by taking 300 pictures, I get a lot better control on the statistics, and I also find more white cells for my count, which allows me to get a better feel for the total white count. For example, we've moved the field of view. There's another neutrophil right there and another eosinophil right there. Now, there are 5 types of white blood cells that I will distinguish during my counting. The ones I'm most interested in are lymphocytes, followed by neutrophils, and then the other 3 types, which are eosinophils, like this one, monocytes, and basophils, I'm not that interested in. but I'll identify them just for completeness. So what I'm going to do now is I'm going to move around and I'm going to find one of each type of cell and show you what they look like. I should say I'm going to find one of each type of cell except for basophils, because basophils are very rare, and although I've looked at a couple of hundred blood smears like this, I've only seen 2 basophils. So the chance of finding one in this blood smear is just about 0. Okay, I'm going to go find a blood cell and we'll take a closer look at it so you can see how I distinguish different types of white blood cells. Okay, the first blood cell I found was an eosinophil. Now these are not very abundant, but they're very distinctive in that they have a sort of pinkish cytoplasm around a bilobed nucleus. And that pinkish cytoplasm makes them very, very easy to identify. They really stand out. And they are, as you can see, these are red blood cells around them. They're much larger than the red blood cells. And this is a 400 magnification picture. And you can see here these little cells are actually cell fragments. Those are platelets. And you can see there are quite a few in this field of view, which suggests that my platelet count is in good shape. I could count the platelets and use the same method to determine my platelet count, but that's really time consuming and I usually don't do it because I haven't had any issues with platelets for about 3 years. Okay, I'm going to look around and find another distinctive white blood cell. This white blood cell is a lymphocyte. Now it's quite distinctive from the neutrophil and the eosinophil in that it has a single lobed nucleus that makes up most of the cell with just a narrow band of cytoplasm around the outside. The nucleus is usually dyed pale blue and the cytoplasm is an even paler blue. Now this is a relatively large lymphocyte. They're usually only about 50% bigger than a red blood cell. The larger they are, the more immature they are. So this is a relatively immature lymphocyte. You can see it's about twice the diameter, maybe 1 3/4 times the diameter of a red blood cell. So these are pretty easy to distinguish from neutrophils and eosinophils. And these particular cells are the ones I'm really interested in because when my leukemia is active, I will have too many of these in my blood. Okay, this is a type of white blood cell called a neutrophil. For a normal person, this is the most abundant type of white blood cell, and it's pretty easily identified because the stain that I'm using dyes the nucleus of the neutrophil blue and dyes the cytoplasm surrounding the nucleus a very pale blue or almost transparent sometimes, depending on how fresh your stain is. And you can see that this particular cell has a 1, 2, 3 lobed nucleus. And that's pretty characteristic of neutrophils, a multi-lobed nucleus. Anywhere from typically as low as 2 to maybe as many as 5 or 6 lobes. But they stand out pretty well. They're also, as you can see, about 4 times as big as a typical red blood cell, which are the cells that surround this neutrophil. So these are easy to identify and they really stand out in the slide. Now this is a cell called a monocyte, and it's the last one I'm going to show you because the only other type of cell is a basophil and I doubt I'll find one. Monocytes have a fairly large nucleus but doesn't occupy the full cell volume. There's quite a lot of cytoplasm around it. They're also very large cells. You notice this thing is about 3 to 4 times the diameter of the red blood cells that surround it. And if you look at the nucleus, you can see there's a little indentation in the middle. That's pretty characteristic of monocytes. So basically what I'm going to do is I am now going to take about 300 pictures of this blood smear, and then I will go back after I take the pictures and I will count all the white blood cells that I find, identifying them as I go and keeping track of how many of each kind that I find. And when I'm done with that, I will go back and use the results of my counting to calculate my white blood count. And so I am going to go do the counting now. So right now I'm going to go out and take all the pictures, which is pretty straightforward. I'll just go back down to turn this down just a little bit. Go back down to my 100 magnification where I do my photography, and I can take a picture just by going up here and clicking on the snap button, and it takes a picture. I could have focused that one up a little better, but you can see the red blood cells are easy to spot, and here is that monocyte we were just looking at. So they're pretty easy to distinguish from red blood cells. So it's actually very simple when I go back and look at all these pictures to count the white blood cells. Okay, I'm going to go take a bunch of pictures and do some counting, and I'll show you the results after I finish.
Here are the results of counting the white blood cells in the pictures. Altogether, I ended up taking 338 pictures. When I went through those pictures, I found a total of 489 white blood cells of all types. So when I divide the number of white cells I found by the number of pictures I took, I get 489 divided by 338, which is equal to 1.447. I can use that number and plug it into my calibration, and when I do that, I get a white blood count of 3.02, which corresponds to 3,020 white blood cells per microliter of blood. As I mentioned earlier, while I was counting the total number of white cells, I kept track of the types of white cells that I found, and these are the results of that count. I found 45 lymphocytes, 410 neutrophils, 23 monocytes, 11 eosinophils, and as I expected, 0 basophils to give me my 489 total white cells. Now I can use the relative proportions of these in conjunction with my result of a total white count of 3.02 to calculate what's called the white cell differential, which is the abundances of the individual types of white cells, which we can see here in the column labeled calculated count. Now these are the numbers that I'm looking for to determine if I need to give my oncologist a call. And just looking at these numbers, I can say that no, I do not. Everything looks pretty much the same as last time I did this. So that is the reason that I did this white blood cell count at home. Okay, that wraps up this video of how I do my own white blood count at home using a few simple things: a biological microscope with a digital camera, a laptop computer, and a couple of simple chemicals. Some methanol that I bought at the auto parts store. It's a product called Heat. And a blood stain that I bought on Amazon. Thanks for watching. Hope you enjoyed it. And don't forget to subscribe to my channel and give me a thumbs up if you liked the video. Thanks again for watching.